Hello learners, myself Dr. Sedhupathy, Assistant Professor, Department of Computer Science with Artificial Intelligence and Data Science, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. So today's topic for discussion will be systems calls in operating system. Agenda for today's discussion is system call, which is what actually system call is inside an operating system. Example of system call. Example, standard application programming interface, system call implementation, API system call on OS relationship, system call parameter pausing and types of system call. So what actually system call is? How it is actually returned? System call is a programming interface to the services provided by the operating system. Typically, system calls are returned in the high-level programming languages like C and C++. Almost system calls are accessed by programs via high-level application programming interface rather than direct system call use, which means system calls are always accessed by APIs. Here, three most common application program interfaces are Win32 API for Windows machine, POSIX API for POSIX based computing operating systems, which includes Unix, Linux and Mac OS versions, and Java application programming interface for Java virtual machine. Here is how system call implementation happen. Typically, a numeric number is associated with each system call. The system call interface maintains a table indexed according to the numbers associated in the system call implementation program. The system call interface invokes the intended system call in operating system kernel and returns its status of the system call and any return value. The system caller need know nothing about how system call is implemented or installed. Just need to obey API and understand what operating system will do as a result call. Most details of operating system interface hidden from programmer by APIs. It actually managed and organized by runtime support libraries like set of functions built into libraries included with compilers. Here is a diagrammatic representation of application program interface system calls with operating system. User application runs in one side and implementation of system call runs in the system call interface on the another side, and the user mode and the kernel mode interface, which is together system call interface, acts in between user application and the kernel application implementation. And there are types of system calls, depends on how user requests, what type of hardware component is accessed, and what type of software actually requested by the user. Here is the first type of system call is process control. Actually, it creates processes, terminate processes. Also, we can say like end and abort, load and execute. And also you can able to retrieve or access attributes of the processes, and also you can set or define process attribute values, and waiting time, waiting for an event, signaling an event, making or creating memory and freeing memory, or finding memory error, debugging bugs. So these are all belongs to process control system calls. And here is the file management system call. When you creating a file, deleting a file, or opening an existing file, or closing a file after using, and reading data from the file or writing data into the file and repositioning the content inside a file, and get and set file attributes like read-only property or a random access property. These are all attributes or belongs to file management system call. The next thing is device management system call. Actually, it requests a device or release a device. It may be, for example, a user is requesting to print a certain page, and the printer device is requested. After the printing process completed, the request or system call releases the printer. Also, read, write, repositioning operations, getting and retrieving or setting device attributes, and logically attach or detach devices from the operating system kernel. And with the continuation, another type of system call is information maintenance. It may be a looking soft, but actually it maintains lot of data, lot of system related data. We can say example like setting date and time, or setting, releasing or retrieving date and time of the system, and getting system data or setting system data, processors, file, device attributes. There are a lot of things happen. Lot of informations can be retrieved and assigned by means of information maintenance system call. And communication system call. You can create or delete communication connects, and if you want to communicate some data from one user to another user, you're supposed to create the communication path or create communication channel. Once you use the channel, after that you can delete that communication connection or channel. And also you can send and receive messages from and to the client by using message passing model or host name or process name. This is actually achieved by client server model. Also, there is another concept for communication is shared memory model, which actually creates and gain access to memory regions. It's like transferring status information, attach or detach remote devices from the main memory. And another type is production. Production is nothing but you can install antivirus software for virus protection. It actually control access to resources. Sometimes you can enable or disable certain hardware components, and you can also get or set all permission for the applications. And here is some of examples of system calls. How process controls from the Windows machine and as well Unix machine, how file management is achieved, and device management, information maintenance, communication and production. These are all actually types of system calls. And the second column contains Windows operating system example system calls, and from the right side third column Unix operating system calls are demonstrated for your understanding. Thank you my dear learners for your patient listening, and I will see you with some other interesting topic related to operating system in the upcoming videos. Thank you so much once again.